Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about some rules or some conditions that will help you to easily determine the determinant of a matrix. Okay, and we're going to start off with this idea or this theorem that describes the conditions that yield a zero determinant. Okay, so if A is a square matrix and we have either one of these conditions as being true, therefore the determinant of that matrix is going to be zero. It is quite easy to actually guess the value of this determinant without having to go through the long process of finding the cofactors, for example. Okay, so let's see the first condition given here. Well, it says that if you have an entire row or entire column consists of zeros, immediately the determinant of that matrix is going to be zero. Well, you can try and do the process if you want, but at the end of it, you will get the answer is zero. So it helps to know theoretically what the answer is, so that when you do the process, you sort of able to see or to guess whether your result is correct or not. Yes. Well, if you look at this matrix given here, the entire row here is 0. Therefore, the determinant of this matrix is going to be equal to 0. Another condition is if you have two rows or columns that are equal. So this is an example of the matrix where you have the first row exactly equal to the third row. Therefore, if you go through the long process of finding the cofactors, at the end of it, you will get the answer here is 0. And the third one is one row or one column is a multiple of another row or column. So you can see that this is 1, -2, and 4, and this is a row that is obtained by multiplying this with 2, and therefore the determinant of this matrix is 0. Okay. All right, now if let's say you have a matrix product of A and B, so determinant of that is equal to finding the determinant of A multiplied with determinant of B. So usually this process is easier than when you do the multiplying process of two matrices first and then finding the determinant of it. Okay, and then if you have n by n matrix, K is a scalar constant. Therefore, the determinant of Ka is the same thing or is similar to taking out K and considering exponent n, where n here is the size of the matrix, referring to the size of the matrix here, and you multiply that with determinant of A. So that is the second theorem on this page. And finally, if A is a square matrix, then determinant of A is going to be equal to determinant of A transpose. And we shall look at the examples related to all these three theorems here. So, for example, here is our matrix A. Show that the determinant of A is equal to determinant of A transpose. Well, we can start off by considering finding the determinant of A. Well, to find the determinant of A, what we can do is we can consider the second row expansion because it have most zeros on it. Yeah, so we're going to consider the second row expansion, and therefore the determinant of A is going to be 2 times with C 2 1. So the position of 2 is at 2 1, second row, first column, and the rest here are going to be 0. So the formula is just this one, 2 times C2 1. Okay. And what is C2 1? So we need to be able to find what is C2 1. So C2 1 can be obtained if you consider M2 1. M2 1 can be obtained by deleting the second row and the first column. So you will have this result, -2, -1, and 5. And the determinant of this 2 by 2 matrix can be found by multiplying 1 and 5 minus, this is going to be +2. So the result here is 3. So what is C31? C31, well, C21. C21, well, 2 plus 1 is 3. 3 is an odd number, so it has a negative sign. Negative with 3, it's going to be -3. And I'm going to supply this result right there. Therefore, the determinant of matrix A is just 2 times -3, which is -6. So that's the determinant of matrix A. Right. Now, I'm just going to show that we will get the same result here when you consider finding the determinant of A transpose. Well, to start off, let's consider what is A transpose. So on this part here, A transpose is just, well, 3, 1, -2 here becomes the first column. So this is 2, 0, 0, -4, -1, and 5. That is the third row. It becomes the third column. And well, if you want to find the determinant of A transpose, you need to choose which row or which column that you want to expand. And I think it makes sense to consider expanding the second column. And why is that so? Because we have the most zeros in it, and it makes our process of finding the determinant of that matrix very much easy. Okay. Therefore, here we will have this position. 2 is at the position of row 1 and column 2, so it will be multiplied with C1, 2. First column and first row and second column, so C1, 2, yes. The rest of it are 0, so I'm just like skipping the first step. So I just write down determinant of A transpose can be obtained by this formula, which is 2 times with its cofactor at position 1, 2. So here is at position 1, 2, the first row and second column. Okay. Right, next is to find the value of C1, 2. So C1, 2 is just first we got to find what is M1, 2, which can be obtained by deleting the first row and second column. So we get this matrix, -2 and 5. And this is just, well, this is a 5 minus, this is 2, which is 3. And if I want to find what is C1, 2, 1 plus 2 is 3. 3 is an odd number. Therefore, you will have a negative sign. Negative with 3 is going to be -3, yes. This result will be supplied inside here. So here, what we have is determinant of A transpose is going to be 2 times -3, which is -6. All right, so this example is related to understanding this theorem, determinant of a transpose. Okay. Now let's look at another example. Suppose that K is equal to 2, A is a 3 by 3 matrix given as such, and you are asked to show that determinant of Ka is the same thing as doing this process, which is taking out K first and considering the exponent n, and then you multiply it with determinant of A. So let's start off with finding this one first, Ka, okay? K times A is going to be 2 times with this matrix, 1, 2, 1, negative 1, 4, 0, 5, 1, 3. And that is equal to 2, 4, 2, negative 2, 8, 0, 10, 2, and 6. So this is the matrix Ka. And in order to find the determinant of that, we can consider, well, I think we can consider the third column expansion. Okay, so what we have is we're going to write down finding the determinant of Ka is equal to 2 times C 1, 3 plus 0 times C 2, 3 plus 6 times with C 3, 3. And of course this one can be cancelled out, so actually what we have is just this part here, okay, plus, okay, let me just write down, plus 6C33. So that's the formula based on the third column expansion. Now what we need to do is I need to find what is C13. So in order to find C13, we start off with finding M13, which can be obtained if you consider deleting the third row and the first column. So we have this matrix, negative 2 and 8, 10 and 2. And so the determinant of that can be found by, this is negative 4 minus 80, and this is just negative 84. So what is C13? Well, 1 plus 3 is 4. That is an even number. Therefore, we will have a positive sign. So positive negative 84, it's going to be negative 84. Okay. So I'm just going to, so we're done with C13, which the result of that can be, inserted right here. Now, next is to find what is C33. Well, C33, in order to get C33, you need to consider M33, which can be obtained if you delete the third row and the third column and the third row. Okay, so here we have matrix 2, 4, negative 2 and 8, and this is just 16 minus negative 8, so that is 24. And C33, well, 3 plus 3, 6. 6 is an even number, therefore you have a positive sign. Positive 24 is going to be 24. And that result would be inserted right here. So I'm going to insert the result now. 2 times negative 84 plus 24. And what is the final answer? So we have 2 times negative 84 plus 24. The result is negative 144. Sorry, not 24, plus 6 times 24, yeah? 6 times 24. Again, let us do this. So 2 times negative 84 plus 6 times 24 is negative 24. So that's the determinant of K times A matrix. So this part here. And then we're going to show that if you consider the right hand side, this process here, the result is the same with what we have just obtained, which is negative 24. Yes, so that's what we're going to do next. And I'm just going to erase this part here because we are done with this one here. Okay, so now I'm going to focus on this one, doing the process given on the right hand side of this equation. Well, k to the power of n, determinant of A, is going to be 2. This is a 3 by 3 matrix, so 2 to the power of 3 times with determinant of A matrix. So this is 8 to the power of 3 is 8 times with determinant of A. Well, what is determinant of A? Therefore, determinant of A can be obtained if you consider 1. Okay, I'm just going to consider this first column expansion. Third column expansion. Okay, this is the third column expansion. Well, this is just 1 times C13, yes. 0 times C23, which is going to be 0, plus 3 times with C33. Okay, so that is what's going on here, the formula to find the determinant of A matrix. Well, now what we have to do is we need to find what is C13 and what is C33. For that, we need another level of showing our work. So C13 can be obtained if you consider M13, and M13 can be obtained if you delete the first row and the third column. First row, third column, and you will have this matrix, negative 1, 4, 5, and 1. And this is just negative 1 minus 20, which is negative 21. Therefore, C13 is going to be 1 plus 3 is 4. 4 is an even number. Therefore, the sign is positive. Positive negative 21 is going to be negative 21. So that is C13. Next, I need to find what is C33 by considering this minor first. And M33 can be obtained if I delete the third row and third column. So I will have 1, 2, negative 1, and 4, and that's just 4 minus negative 2, which is equal to 6. 3, in order to get C33, well, 3 plus 3 is 6. 6 is an even number. Therefore, we have a positive sign. Positive 6 is going to be 6. And we're just going to plug in those results here right on this formula. So C13 times 1 is negative 21. Negative 21 plus 3 times 6. Well, that's going to be negative 21 plus 18. So negative 21 plus 18 is negative 3. So that is the determinant of A. Therefore, Kn determinant of A is going to be 8 times negative 3, which is going to be equal to negative 24. And we are able to show that indeed the right hand side and the left hand side, they are equal and they yield the same answer. Okay, and this example here is related to, well, this part. this part. Okay, and finally, the last example that I would like to discuss on this video here is this one, and we're going to determine that if you multiply two matrices together, you'll be able to find the determinant or the result of that, and the result of that is equal to finding the determinant of those two matrices separately and then multiplying the result. Okay, so we're going to just focus on this part first, how to find the determinant of two matrices multiplied together. Well, here we have A times B, and this is 2, -1, 3, and 5, with B is 4, 0, -7, and 2. So the result of this multiplication is going to be, well, 2 times 4, 8, plus 7, so this is 15. And then 2 times 0, 0, so this is -2. 12 plus -35, it's going to be -23. 0 plus 10, so this is 10. This is the result of matrix A multiplied with matrix B. Now, to find the determinant of AB, this is quite easy. We can obtain the determinant of this matrix by cross multiplying these two items here. So we have 1, 5, 0 minus, this one is going to be positive, positive 46, so minus 46, yes, and so the result of it is going to be equal to 104. Sorry, this is determinant of AB. Okay, so we're done with getting the result for this process described here. Now what I'm going to do next is I'm going to focus on showing that if I do this process, the result here will be the same as what we have just obtained here. Okay, right, so what is determinant of A? Determinant of A is just, well, we have 2, -1, 3, and 5, and this is equal to 10 minus -3, which is equal to 13. So that is the determinant of A. Next, the determinant of B matrix. This is equal to finding the result of this. We have 4, 0, -7, and 2. And this is just 8 minus, well, this is 0, which is 8. Therefore, determinant A times with determinant B is going to be 13 times 8. And the answer here is, the answer here is equal to 104, which is clearly the same thing as what we have just obtained if you follow this process on the left hand side. So the process on the left hand side here is equal to the process on the right hand side. Okay, I think that's all for now. Thank you very much for watching. See you again in the next video.